Hi, this is Jason Baker, and welcome to week 10 of our DevOps and Cloud Infrastructure course. This week, we're going to talk about configuration management. And this is kind of an extension of the previous week's lecture where we covered infrastructure definition. With infrastructure definition tools, we're using these tools to create our, our infrastructure resources like our computing instances, our storage, our network configuration. With configuration management, we're focused on our servers. So we're focused on our computing instances, and we use configuration management tooling to configure our application services, our applications, our data, and our systems configuration on those computing instances. Let's look at the agenda for this week's lecture. First, I'll talk about a few different application deployment strategies that you can utilize to deploy your applications to a fleet of servers. We'll talk a little bit about immutable infrastructure and why immutable infrastructure is becoming a preferred way to deploy our applications in modern cloud computing infrastructure. I'll give you a hands-on demonstration of a tool called Packer, which we use to build things like AMIs and configure the software on those AMIs. Then I'll talk a little bit about configuration management, and most of the lecture will focus on a specific configuration management tool called Ansible. Let's dive right in. So deployment strategies. Well, once you have created and built your application, how do you go about deploying that application to distributed infrastructure? The strategy that you follow to deploy your application on one server is very different than the strategy that you might use to deploy your application to a dozen servers or even 100 servers. When you're deploying your application to distributed infrastructure, you have to keep in mind that there's always this trade-off between the speed of your application deployment and the amount of risk that you are incurring from that deployment strategy. So there are certain deployment strategies which are really fast, but more risky, and there are other strategies that have much less risk, but are also have slower deployment speeds. And the other thing to keep in mind is that cloud computing and cloud infrastructure provides for some particular deployment strategies that really weren't possible. Well, they were possible, but would have been really expensive to implement in the past if you were using traditional infrastructure within your corporate data center. Because of the cloud pricing model and the elasticity of cloud infrastructure, there are deployment strategies that we can take advantage of in the cloud. Okay, so let's look at a couple different deployment strategies. The first one is really the simplest one, and that is we have a single server and we want to deploy our application to that server. This single server deployment strategy is really common in a testing or application development sort of situation. Maybe you have an application, maybe you have a production service that isn't highly available, doesn't need to be highly available, and only needs to run on a single server. Well, deploying your application to a single server is very quick and it's very easy. When you deploy your application to that server, there's going to be some sort of service outage. There's going to be some period of time when you need to take down your service or stop your application while you are replacing that application with a new version. So your your service or your application will be unavailable for a period of time. And when you deploy your application to that server, there's if you need to roll back the changes that you've made, you basically just need to either uninstall your software or reinstall the previous version of your software application. So single server deployment strategy, very simple. We're just simply updating our software on a single computing instance. Where things become more challenging is when your application is deployed across multiple servers. You might have multiple application servers that are all behind an elastic load balancer. The elastic load balancer is distributing requests across those servers. How do you go about upgrading and updating your application across the fleet of servers? Well, there's a couple different strategies. The first strategy is what we call a big bang deployment strategy. And with this strategy, you're essentially deploying your software across all of those servers all at once, all at the same time. And this is a fairly common strategy if you have a small set of servers. Maybe you only have a handful of servers that you need to update. It's a quick process because you're updating your application across all these servers at the same time in parallel. And you might be wondering, well, how do you go about updating your software across all these servers? And we'll look at a tool, Ansible later on that you could use to do that. But there's a variety of tools in the marketplace. There's an open source tool called Capistrano, which is popular. And there's a variety of other tools that you can use to deploy your software onto multiple servers at the same time. Well, with this big bang strategy, you have a problem, and that is when you deploy your software across all of the servers at once, the servers are going to be unavailable for a period of time because your existing software is either going to be removed or it's going to be shut down while your new software and new code is being deployed in each one of those computing instances. And so that the big bang deployment might be really fast, but it's also risky because your customers are going to experience a service outage. And the other thing is if you need to roll back the deployment, then you basically have to install the previous version of your software code again. So it can be challenging to roll back any changes that you made to these computing instances during your software deployment. So when you think of big bang deployments, think of a very fast and speedy deployment process, but one which is also very risky. The second deployment strategy that you can utilize is what we call a minimum in service deployment strategy. And with a minimum in service deployment strategy, what you're essentially doing is you're specifying that instead of deploying your software across all of your servers in your fleet of servers, you're going to keep a minimum number of servers up and running and supporting your existing customers. And then you're going to have a second set of servers which are being updated. So if you look at the example on the right, let's say we have 6 application servers here. And we've specified that we want to have 2 servers minimum in service at all times, meaning that we'll have at least 2 servers at all times supporting our customers. So with this strategy, what we would do is we would update 4 of the servers out of the fleet of 6 servers. So you see we have 2 servers that are still supporting our customers. They still have the old version of our software application. And then once the 4 servers that we're updating have been updated, then we'll shut down and update our application software on the other 2 servers that were the original 2 servers that were the servers that were the minimum number of servers in service. And once those 2 servers have been updated, now our code is deployed across all 6 servers in our pool. Well, the benefit of this strategy is that we can support larger environments, and our customers will not experience downtime because we always have a minimum number of servers that are supporting our customers. We also have the ability to potentially roll back the changes that we make. So we might update these 4 servers and then quickly perform some automated testing. And if automated testing determines that there's a problem with the software updated on these systems, then we can roll back the software update on those systems. And again, our customers are hitting these other 2 servers, so they're not seeing the changes yet. They're not experiencing those changes. So this deployment strategy is a little slower, obviously, than Big Bang because we're not updating all the servers at once, but there's less risk. Another way to sort of roll out these changes to our environment is what we call a rolling deployment, or sometimes it's also called a canary deployment. And in this case, what we do is we specify that we want to upgrade a certain number of servers within our pool at each time. So we might say that we want to upgrade 2 servers at a time out of our pool of servers. So we have 6 servers, and here we're going to start updating them. So we're going to update the first 2 in the pool, and then the next stage we'll update the next 2, and then finally we'll update the last 2. And after we've updated the last 2, now all 6 servers have been updated with our new software. So the benefit of this process is that we're just slowly updating our servers, our software code on our servers, and we're sort of slowly rolling it out. And as we're rolling it out, we're also doing some testing. And if we see that there's a problem, then we can roll back those changes. So the benefit of this is that of a rolling update of a canary deployment is that we're really minimizing risk because we're slowly introducing the software updates in our environment. The downside is that it's simply slow. If we have like 100 servers, it could take a long time. It could take an hour to deploy our software update across the entire pool of servers. And you have to keep in mind from an application development standpoint, your application platform has to be designed to support 2 different versions of your software running simultaneously. Because your customers might be accessing one set of servers that are running the old version of your software and another set of servers which are running the newer version of your software code. So your platform needs to be able to support 2 versions of your software code simultaneously. It's definitely doable. Lots of companies perform rolling deployments. It just takes more time and effort, and there's more complexity involved because you're having to sort of juggle the 2 different versions of your software code. A blue-green deployment strategy is another way of deploying our software to a distributed set of servers. And this is very different than the previous 2 strategies, which really leveraged this rolling update sort of process. With a blue-green process, what we do is we create an entirely we take a new production environment. We create a second environment which sort of mirrors our original environment. So let's say we have three application servers in our platform. With a blue-green deployment strategy, we would have three application servers, which we would call our blue servers, and then we would have another set of application servers, three servers, called our green servers. Now, customers are only accessing either the blue servers or the green servers at any given time. And we have the ability, using our Elastic Load Balancer or something like Route 53 service, to be able to switch customers from one set of servers to the other set of servers. We start out by deploying our software application to the blue servers. And our application runs for a period of time. It might be days, weeks. And then we have a new software deployment, a new code release. Instead of upgrading our blue servers, we would deploy our code to the green servers. And once our code has been deployed to the green servers, then we would simply make a change in our application load balancer, maybe in the target group or in Route 53, and we would switch customers so that customers are now using the green servers. So we're just deploying our application either on the blue servers and the green servers, and we're switching back and forth. So the next time I need to make a code update, if my current code is running on the green servers, I would apply that code update to the blue servers and I would switch it back. So I'm sort of switching between these two environments as I'm making code updates. The benefit of this is sort of twofold. One is we can rapidly switch customers from blue to green or from green to blue. So it's almost like a big bang deployment in the sense that we can immediately upgrade all of our servers all at once, so to speak, because we're just simply repointing customers to a whole new set of servers. And if we point our customers to the new set of servers and we find out that there's a problem, then we can quickly switch customers back. So we have the ability to very quickly roll back changes just by simply redirecting customers to the previous server pool. This blue-green deployment strategy traditionally was very expensive to implement, and it wasn't all that common because you think about it, a company buys all this infrastructure, all the computing and storage and network infrastructure in their data center, and to implement a blue-green deployment strategy, they would essentially have to buy two of everything. And so that could get very, very expensive. There were definitely companies that were doing it, but this was not as common of a strategy because it was very expensive. But in the cloud, as you know, it's not as expensive, right? And we don't necessarily need to keep both the blue and the green, um, our blue and green resources up and running at all time. We can keep them both up and running when we want to make a migration or upgrade all our code. But once we've updated all of our customers and things look good, then we could shut down the previous blue or the previous green instances to save on costs. And so we can use the elasticity of the cloud to rapidly spin up sort of a copy of our current infrastructure, and we could use it then for these blue-green deployments. Blue-green deployments are becoming very, very common in modern cloud applications. I'd say that the canary deployments are common and the blue-green deployments are also very common today. So just to summarize the challenges that we face when we're deploying our applications to distributed infrastructure, we face this challenge of how do we deploy our application uh, and cause minimum disruption to our customers. And it's something that we call zero downtime deployment. How do we minimize the disruption to our customer services? How do we support multiple versions of our application simultaneously? If we have a rolling upgrade process, then we need to be able to support two different versions of our application. Now, if we have a blue-green deployment process, then our customers are only going to be accessing one version of our application at a time. So we could switch them from one version to the other. The challenge with supporting multiple versions of our application is usually dealing with database concerns. So if you have multiple versions of your application running simultaneously, those applications are probably communicating with some sort of backend database service. That backend database has to be able to support those multiple versions. So the database schema has to be aligned with the different versions of software code that you're running. Also, if your application is using APIs, those APIs also need to be able to support multiple contract versions as well. And then finally, the other big deployment challenge is how do you deal with a failure situation? You've deployed your code to the environment, things have blown up, and you need to quickly roll back to the previous code that you were using. And you've seen that some of these deployment strategies are much faster than others. If you have a big bang deployment process, um, that's sort of like the point of no return, right? I mean, if you could roll back, but it's also going to be another service outage for your customers. A canary or rolling deployment strategy it gives you a little bit more time. You can slowly roll out your changes, and if you're testing properly and you encounter some sort of issue, then you can halt that upgrade and then roll back those systems that have been upgraded. With a blue-green deployment, you can quickly switch from the blue environment to the green environment and back. A lot of companies, honestly, today, and instead of trying to roll back the changes, they have a policy of trying to roll forward, which means that instead of if they encounter some sort of critical bug in production, instead of trying to roll back the application to the previous version, they just quickly fix the bug and push out the changes and essentially do another code release with the fixed code in it. So that's sort of a rolling forward type of strategy. Okay, so uh, we talked a little bit about uh, deploying our software applications to distributed servers. The next thing I want to talk a little bit about is the life cycle of our application servers. Each application server has a life cycle, and that life cycle usually begins with the launching of the server. When you launch a server, you start by selecting a template, right? And in our EC2 instances, we're selecting an Amazon machine image, and that machine image serves as the template for our instance. So we start with this template, and we use that then to create a new server. We create the new server, the server's up and running. We might, over time, update that server. We might delete the server. We might replace the server with a new instance that's running a newer version of our template, a newer version of our AMI. And every server that we create is in one of these stages of the life cycle. It's being launched and created, it's currently running, or it's being terminated and replaced. So when we create a new server, how do we do that? And in this class, oftentimes when we've been creating servers, we've been logging into the server and manually installing software, or we've been writing short shell scripts that automate the installation and configuration of software on our systems. But what we ultimately want to be able to do is create servers and configure servers using automation. And when we do that, you have to think about all the different components on a server that you need to configure. And every server that you work with consists of a number of different components. Things like the infrastructure definition. In other words, that's the type of server. What is the instance size? How much memory does it have? How many storage volumes are attached to the server? Every server has an operating system. In our class, we've been using the Amazon Linux distribution, or in some cases, we've used the Ubuntu Linux server distribution. Every server has software installed, things like Apache and Nginx and MySQL database. The operating system and our applications also have configuration. We can configure the operating system to work a certain way or configure our applications. And those configuration files are oftentimes like JSON files or YAML files or XML type files. And then finally, we have data on our servers, right? We have our application data, we have our customer data, we might have databases, that sort of data that's installed in our application. So these are all different components that you'll find on a server. And we have to think about, well, how do we automate and manage all of these components? Well, last week you saw that we could use an infrastructure definition tool to define our server infrastructure. We can use tools like CloudFormation, and we can use Terraform by HashiCorp. Uh, we can use auto scaling to automatically create new instances for us based on a launch configuration. So we can use those tools to create the computing infrastructure. And when we're creating that EC2 instance, we selected a server template, an image, right, called an AMI. And that AMI contains our base operating system and some software and configuration. Once we've launched our server using our AMI, we can then deploy software and configuration to it. We might use a tool like Capistrano to deploy our software, and we can use a variety of configuration management tools to configure our server, to define the configuration of our operating system and our applications, to define what application services should be installed and what data should be on our server. And what we'll learn here in a few weeks is that we can actually potentially package all of these things in something called a container using a technology called Docker. And we'll learn more about that in week 12 in the course. So I just want to give you kind of the full picture of sort of the tooling and the things we ought to think about when we need to configure our EC2 instance, configure our application server. Well, when we're configuring our application server, we can use that infrastructure definition tool to create the server. The infrastructure definition tool is going to need to apply a template to the server that's being created, right? It needs to apply an AMI. Well, how do you build that AMI? There's two different approaches, two general approaches that you can take. One approach is what we call baking the image. When we bake an image, what we're doing is we're essentially pre-generating a template or an AMI that contains the operating system, all of our software components. It might include the configuration of those software components. So everything that we need on our server is going to be baked right into the AMI. So one example of this is what we've done previously in the course is we've created a snapshot of an existing server, and we use that snapshot to create an AMI. We could then launch a new server using that AMI, and we would essentially have like a copy of the previous server that we are running. And so that new AMI has the operating system and all of the software and configuration baked right into it. So the benefit of this approach to baking our software images is that it allows us to launch new servers very, very quickly because everything is already in place on the image. Now, the downside is that if we need to frequently change the software or configuration that we're using in our environment, then we might need to frequently build new images. We might need to have a way to manage all of these images that we're creating. And traditionally, baking images was kind of could be kind of a challenging process depending on the amount of change occurring within your environment. The second approach to building a server is what we call frying the server. And when we fry the server, essentially what we're doing is we're launching a server with a base operating system like Amazon Linux operating system. We're using the base Amazon Linux AMI. And once that AMI starts up, then we're going to go through a sort of like a bootstrapping process that's kicked off using something like EC2 user data. And that might kick off something like a shell script, which calls a configuration management tool. And when the server is booting up, then it's going to install this. A script is going to install all the software that we need. It's going to apply all of the configuration changes to that server. It's going to do all that on the fly as the instance is launching for the first time. So you're not baking all of your software and changes into the AMI. You're using a very base, simple AMI. You're booting that up, and then you're applying all the changes to the system when it first boots up. We call that frying the server. And so the big benefit of frying the server is that you don't have to like manage all these images. You don't have to bake your software into the images. You can just have it deployed at launch time. Now the downside of frying a server is that it might take a long time to deploy your software. Maybe your software takes and your configuration takes 20 minutes to deploy. I've worked on configurations like that literally took 20-25 minutes. So if you need to launch servers very quickly, maybe the servers are part of an auto scaling group and you're trying to scale up the amount of computing resources you have to meet new customer demand. If you're frying the servers, then those servers might not be available for 5, 10, maybe 20 minutes while they're going through this bootstrapping process. And in that case, baking the servers makes a lot more sense.